Good morning, everyone. I am Dr. Ganapathi Raju, working as a professor in HOD Department of IT, GRIET. As a part of my project Drona, in track 1, I have completed track 1 AIML and track 3 digital transformation. And as a part of track 2, phase 2, in project Drona experimental learning, I have chosen set 2. That is comparative study of various classification techniques, okay, on the Titanic data set. Now, first let me discuss about what is the data dictionary of Titanic data set. Titanic data set describes the survival status of individual passengers on the Titanic ship. In April 15th, 1912, the largest passenger liner collided with an iceberg during voyage and killed around 1,500 people. Now, the Titanic.csv file, we had around 891 rows of the data and 12 features which are given to us. Okay. Now, the first feature is the survival feature, whether the passenger is survivable. Here we have two variables. 0 means survival, no. 1 means survival, yes. Now, the other attributes such as passenger class, sex, age, siblings and spouses, and parents and children, ticket, fare, cabin, and embarked. These features are called as input features. Okay. They will be represented as capital X, and the target variable is called as survival. Okay, survival is a target variable. This will be predicted variable by. Now, this problem comes under supervisor learning classification. Okay, so this topic comes under classification. Okay, so I'm going to apply various machine learning classifiers to build a machine learning model to the Titanic data set. Basically, if you want to implement any problem in the machine learning, they will be a form of steps. We need to implement them with different form of steps. First one is we need to import various libraries into the Anaconda Jupyter notebook, and we need to load the CSV file into the pandas, where we will represent the data in the form of data frame. Then, if the data set consisting of missing values, we need to go for data imputation. Here, I have used a technique called box plot technique. And then, if the data consisting of categorical, we need to apply data encoding technique. I have applied one hot encoding technique. Next one is, in order to keep the data in a between 0 and 1 in a specific range, I used min-max scaler. Then I have done a little bit exploratory data analysis using libraries such as Matplotlib and Seaborn. Then I have built classifier models by using KNN, decision tree, Naive Bayes, logistic regression, and SVM classifiers using scikit-learn. Finally, I have applied all the metrics for validation such as accuracy, confusion matrix, precision recall, F-measure, AUC, and ROC scores in a given problem. My problem starts with the data set, which is already given by the HICIA team, and I have done various data pre-processing techniques such as data imputation, data encoding, normalization, and exploratory data analysis. Then I have done for a little bit about exploratory data analysis. Then we have divided the data into 70% of the data for training and 30% of the data given for testing. Then I have applied various machine learning algorithms. Then I have done some evaluation techniques using accuracy, confusion matrix, precision and recall, F measures. Now, before going to show about comparative study results, I wanted to show you how I have implemented the case. Initially, I have imported all the libraries, NumPy for numerical applications, Pandas for data analysis, and I have used two visualization techniques, Matplotlib and Seaborn. Then for using min-max scaler, I used scikit-learn pre-processing min-max scaler. Then we have taken five algorithms. One is KNN, decision tree, Gauss, Naive Bayesian, logistic regression, and SVM. Then these libraries are used for metrics. If I'm using any older versions, it will get suppressed by some warning messages. First of all, we need to load the libraries. Then once the libraries are loaded, then we need to load the data set by using pandas object.read_csv. Now I have taken Titanic_train_csv data set, and now I have stored in a variable called train. Now this is the data frame where we can see 891 rows and 12 columns of the data. Out of them, survived is the target variable. Okay. Then first of all, I'm checking whether my data set consisting of any missing values or not. It can be done by using dataframe.isNull.sum. We have identified that from the training data set, age feature have 177 missing values and cabin has around 687 missing values. Okay. Then now I have shown the same missing values in the form of a heat map. It clearly shows that age has around 10% of missing values and cabin has around 90% of the missing value. If any data set consisting of 90% missing values, we'll simply drop that specific column. Okay. Now, then I have done a little bit about exploratory data analysis between survived and not survived. If you observe this carefully, 550 plus passengers are not survived, 0, and 300 plus passengers are survived out of 891. Okay, and these are the ratio of survived with male and female. Then this is about survival ratio between not survived and survived in the form of 3 classes of the passengers. And I have drawn from distribution plots of training of years. Then I have shown how many number of siblings are there in the data set for everyone. Then I'm going for a beautiful concept, how to impute the data. Most of the people will write mean, mode, median. Then in order to identify what is the median of the data, I'm using a box plot. For in the x-axis, I have taken passenger class, and the y-axis, I have taken age. So we can clearly observe that passenger class 1 median is equal to around 38, and passenger class 2 median is around 28 or 29, and passenger class 3 median is around 24 or 25. Same values I'm using for doing imputation process. So I have written a user-defined function, impute_yes, where if passenger class equal to 1, I'm imputing with 37. If passenger class equal to 2, I'm imputing with 29. If the passenger class is 3, if I'm imputing 24. Okay, now after imputation of the process, now if you look at the heat map, now age feature has been gone. Okay, that means there are no missing values in the age. Now you can clearly identify missing values are there only in the cabin feature. So what I'm doing, simply I'm dropping the column. Okay, after dropping this cabin, this is my data set. My data set consisting of passenger ID, survival, passenger class, name, sex, gender, and so on. Then information is a function on the data frame which will give us each and every column and its data types. Okay, now we are going for encoding techniques, because sex and embarked are represented as objects. Okay, but machine learning algorithms doesn't support categorical data. So in order to convert the categorical data into numerical data, I'm using one-hot encoding. It can be done by using get_dummies function. Okay, now let me run one by one. After conversion of the data into, look at here, after conversion of the data into, now into categorical data. Now, if you see the data, there are no categorical data. Okay, now we are dividing the data into input X and output Y. From the data set, I'm dropping the survived feature. Survived is target variable. Remaining all attributes will go to X. Okay, then now Y is a target variable, that is survived, we have copied into Y. Then in order to normalize the data, I'm using min-max scaler. Min-max scaler transforms the given data into zeros and ones. So all the numerical data will be reflected in between zeros and ones. Then I have divided the data set into 70% of the training and 30% of the test by using train underscore test underscore split. I'm passing X is input, Y is output. Then initially I'm applying logistic regression. Then I'm going for fit function. Fit function is used for training. Now train underscore test underscore split function has given 4 arguments. X train, Y train, they will be used for training. X test, Y test, they will be used for testing. Now, if we pass X train and Y train arguments via the fit function, it will be called as training phase. Then, if you want to test it, we have to pass X test argument. If you want to understand more about it, I'll take 1 minute about how it will be divided. Okay, look at here carefully. This is the data set. So we have, initially we are dividing the data set into input X and output Y. Then we are dividing the data 70% for training, 30% for testing. This is called as X train. This is called as Y train. This part is called as X test. This part is called as Y test. By using fit function, I'm using X train and Y train arguments. These 2 arguments are used for training. Then, now in order to test my algorithm, we have a function called predict. Predict function always takes X text as input argument and it is going to return Y prediction. Okay, this is the outcome of the algorithm. This is called as testing. Now it is going to return Y prediction and I have not used Y test for training and testing. Now I have to compare Y test results with Y prediction. That is called as accuracy. Now let me show you. Now let me, once if we pass X test argument for the prediction model, the results are stored in the prediction. Then if you want to go for metrics for classification, confusion matrix will tell you how good your model is by looking at this is 149 is true positive, 69 is called as true negatives, 14 and 35 are called as errors. Now, how to calculate accuracy score? There is a function called accuracy underscore score where we are passing Y test and whatever the predictions we have done by the model, I'm giving them. Now, logistic regression is showing 81.64% as accuracy. Okay, then this is about classification report. Then we can also go for recall score, precision score. They have given around 66% and 83%. Finally, ROC and AUC score, I got around 78%. If you observe this ROC score, it is giving around 82.1%. So this model can be considered as good model. Okay. Now later, I have taken a logic to compare various algorithms, okay, such as KNN, decision tree, Navy-Bayes, logistic regression, SVM. Out of 5 algorithms, Navy-Bayesian and logistic regression has outperformed with 81.64% with other algorithms. Is it okay? Now, we can also extend this program by using hyperparameter tuning like grid search and random search or By using pipeline mechanisms, we can increase the accuracy from 81 to around 84, 85 also we can do it. By using ensemble methods also, we can increase the performance of the algorithm. Okay. I would like to thank HICIA, Task, and Infosys Springboard for giving me this opportunity. Thank you very much. Finally, I would like to thank Shanti Madam for her cooperation.